Hi, you're listening to Avril Sorter recording CCNA Wireless. What we're going to be talking about in this lesson is really about the wireless LAN controller. How does it function? How does it operate? How do access points connect to it? So it's really at the heart of the unified wireless operations. Now, when I first plug in my lightweight access point, it needs to go through a 5-step process in order to get into the ready and connected state. So the first thing that needs to happen is that the access point needs to obtain an IP address. And to do that, it will send out a broadcast message. Once it's made contact with a DHCP server, then it can begin the exchange to actually get an IP address. Then it will go on to discovering the controller. And there's various methods it can do to discover the wireless LAN controller. So one method, which is optional, is it sends out a discovery request as a broadcast message. And any controllers that hear that broadcast message can respond back with a discovery response message. The over-the-air provisioning is a feature on some controllers where other access points which are already associated with the wireless LAN controllers actually send out over the air information about the wireless LAN controller that they're connected to. And so another access point can hear that information from its surrounding access points and use that information. Now that feature is actually off by default, and you want to keep it off if you're doing a brand new installation where you're deploying lots of access points. AP priming again is another option for you, where you basically set up your access point. You can use DHCP option 43, and DHCP option 43 allows the access point to get the wireless LAN controller IP address from the DHCP server. And the other way is to go through the DNS query, and it can look up the Cisco LWAP controller or the Cisco CATWAP controller. So once you've found the wireless LAN controller, you can then send your discovery request, and the controller will respond back with a CATWAP discovery response message. It'll tell it the controller's name, the type of controller, the AP capacity, and the current AP load. The current AP load actually means the number of access points that are currently joined to that wireless LAN controller. The master controller status is actually quite important. When a new access point comes up, it has no primary, secondary, or tertiary controller assignments yet made, and so by connecting to the master controller, it can make sure that it gets the right configuration and also gets assigned primary, secondary, and tertiary controllers. Now, the recommendation here is once you've got all your access points connected on the network, you should actually disable the master controller feature, because new access points will have a preference for connecting or must connect to the master controller. And so as access points has stabilized and already have their primary and secondary, you shouldn't need that feature anymore, and you should actually go ahead and disable it. So now I know everything about the wireless LAN controller, I can go ahead and attempt to join that controller. Now, right after I've done the discovery request response sequence, I need to establish a secure CATWAP connection, and I'm going to use the DTLS protocol, and so I'll go through the DTLS handshaking protocol. As soon as that tunnel's set up, then I will go ahead and send in my joint request, and the access controller will send me back a joint response. Now, the joint request message tells the wireless LAN controller everything about the access point, and that includes the description, the name of the access point, the MAC address, the IP address, and also all the information about the radios that it supports. Is it an ABGN radio? Is it dual mode, etc. Now, once the access point has sent in the request, the controller will respond with a joint reply or joint response message. And this message first of all contains the result code, and the result code will tell you whether this was successful or has failed. If it's failed, what it needs to do is go on and try another controller, and it will keep trying until it finally goes ahead and registers. Also, it'll tell it about the wireless LAN controller images. If the image in the access point is different from that of the controller, the access point will then have to go forward and download the image from the controller and then reboot that new image. If it's the same, that's good. It'll also do a test payload to make sure the communication is effective. Also included in the joint request and a joint reply is actually certificates, or the access point credentials, and the access point must have a valid certificate in order to get a joint response. If it's not valid, the access controller will not respond back to the request. So step 5 is really to make sure that the access point firmware and configuration is consistent with the controller. So it would first check the firmware image, and if it is not the same as the controller, it will request the download and then update itself. Once the AP has successfully downloaded the image from the controller, it'll actually reboot itself with that new image, and then the whole process will start again, going back to step 1. If the current image is the same as the controller, then it can go to the next stage of actually downloading the AP configuration. So the AP simply requests the configuration, and the controller will then send down the configuration parameters. Once all of that's done, your access point is now operational. And one of the important things when you look at the Cisco Unified Wireless Network is to provide redundancy between the controllers. Now when we think about redundancy, it's not just the controller you have to think about, it's also the wireless access points. The way that you get redundancy when you're talking about access points is actually to have overlapping cell coverage. So here I've got 3 access points, and let's say they're operating in the 2.4 gigahertz band on channel 1, 6 and 11. Then because they're on different frequencies, I can actually get them to overlap and still not interfere with each other. And there's several advantages of doing this. One is that if one access point did go out, assuming that you've got access points that are overlapping all around its perimeter, then there's a potential that you can get coverage where that access point was. Now when you plan out your network, if you're planning it just for data, you normally have about 15%, 20% cell overlap. If you're planning out for voice, you want to increase that up to 25, even 30% overlap. Of course, when you do overlap your cells, you do have to deploy more access points, so there is a cost implication, but again, the big advantage here is that you've now got coverage should you have one access point going out. Now, if you're a Cisco deployment, you want to strongly think about getting the Cisco SmartNet support, and that basically provides you access to technical assistance. There's a lot of tools that you can download, gives you access to the different software updates, so you've got the latest configuration on your equipment, and depending on your agreement, you can actually have failed equipment replaced. Once you've got a SmartNet agreement, then you have a contract number, and that's really important that you keep the contract number somewhere close at hand, is because when you phone into the service support center and you actually open a case, then you'll need to have that number with you. Now let's talk about controller redundancy. And there's 3 types of redundancy, or models for redundancy. This is the N+1. So in essence, all of your access points are connected to the primary wireless location controller. And you see that here with the solid black lines in the diagram. If one of those wireless LAN controllers go out, then the access point will switch over to the secondary, the backup controller. The problem is, in a large network, let's say you have a multi-story building with 10 floors in it, and each floor has a wireless LAN controller, and you use one backup wireless LAN controller for all 10 floors. If more than one wireless LAN controller goes out, then all of those access points are going to try and connect to the secondary wireless LAN controller. And it's quite possible that it could result in oversubscription, i.e. not all of your access points will be allowed to join because it doesn't have enough licenses on it. Now, in the N+N controller redundancy scenario, this is where your access points would actually register with both their primary and a secondary wireless LAN controller. And the secondary wireless LAN controller acts as a backup for the other controller. Now, in this scenario, you would want to put your redundant controllers on the same physical network and potentially want to give them the same management VLAN on that network. Now, in the first scenario, the N+1, you had one backup controller for all of your wireless LAN controllers, and so it was relatively inexpensive. In an N+N controller redundancy, what you'd have to do is to make sure that the primary and the backup wireless LAN controller can both support all of the access points that it needs to. In this scenario, you would have to license the wireless LAN controller with the view that it's going to support all of the access points that are currently primary and secondary. And so this can be a rather expensive solution when it comes to licensing fees. And you also don't want to max out those wireless LAN controllers because they're also acting as a backup. So you never heavily load them because there's a potential that access points may need to connect to them in the case of a failure. So our third is our N+N+1 controller redundancy model. And if you look at this diagram, it's a bit like putting the two previous diagrams together in one. And so in this scenario, you have two controllers backing up each other. So some access points are connected with a solid black line into the second wireless LAN controller. And then you have a third controller that then backs up the two primary controllers. This means that if one of the primary controllers go out, what's referred to here, the tertiary, the third wireless LAN controller kicks in and becomes the primary to some access points and a secondary to other access points. So literally, if your primary fails, you go to the secondary. If your secondary fails as well, you go to your tertiary. Now, greater reliability comes at a cost. So this is a more expensive solution. And again, not only because of the physical hardware equipment, but also you need to make sure you have enough licenses on those wireless LAN controllers to support the number of access points that you might need to connect. Now, out of all of the course, I think this is the most important to kind of grasp and to try and understand. Ideally, what you want to have is your wireless LAN controller configured and set up such that you can plug in an access point into any port and it will automatically be able to find the controller, download the necessary image and configuration, and then get going in terms of operation. So we're going to talk about wireless LANs, VLANs, and subnet mapping. So in this diagram on the right, I'm going to describe it in like three parts. So here, an access point is broadcasting in the beacon the SSIDs, and it could have one or many SSIDs. And a client that's listening will say, oh, that's the SSID that I want to connect to. And so it will associate to a specific SSID. Now that access point connects to a wired distribution network which consists of switches and other network nodes. And so the interface on the switch that wireless access point is going to connect to needs to be configured as an access port. Now, an access port by definition only supports one VLAN. And so when it connects to the switch, is forming a connection to the switch, and the switch looks at it as just a dumb device or a dumb host that's not capable of doing any routing. And so the access point will connect to it, form the link, and will route its traffic directly from the access point to the switch. You will want to set up that switch not only as an access port, but you'll want to assign it a specific VLAN. Because what that switch is going to do is it's going to take that traffic and it's going to tag it. It's going to tag it with the VLAN ID that's been assigned to that access port. It'll then forward it based on that VLAN ID in a CAT-WAP LWAP tunnel to the wireless LAN controller. So from a configuration perspective, when you're attaching a access point, and here we're talking about a lightweight access point, we connect that to a port. The only thing we have to worry about is configuring that port to be an access mode and defining it a unique VLAN. So let's now talk about the second part of this diagram. So when that traffic leaves the switch, it is now tagged with a VLAN tag and encapsulated with a header, an LWAP, CAT-WAP header. And it goes through the tunnel, regardless of how many nodes there are, goes hop by hop by hop, until it finally reaches the wireless LAN controller. The connection between the switch and the wireless LAN controller must be configured as a trunk port. Now remember here, I could have different access points, and those access points are connecting to the switch, and all of those are going to be routed to the wireless LAN controller. So the wireless LAN controller must be set up as a trunk in order to receive traffic from different access points which have been tagged with different VLAN IDs. Now it's highly recommended on that trunk that connects your wireless LAN controller to configure it for only the VLANs that need to go to that wireless LAN controller, i.e. you don't want to go VLAN all. And the reason is that if you open it up to other VLANs, it could get traffic that's not destined for it, and then you're going to throw messages out in your logs, etc. So you really want to make sure that the trunking port that connects to the wireless LAN controller is correctly configured in terms of the VLANs. So let's now talk about what happens when I get to the wireless LAN controller. Now the wireless LAN controller is normally connected to a switch and is going to route based on the VLAN ID, so the VLAN tag. And so a wireless LAN controller must be connected to the wired network for the distribution of traffic using an 802.1q trunk. So let's take a look at the interfaces on the wireless LAN controller. So we've talked about how the switch must be set up as a trunk, and here we're showing that trunk connection coming into the wireless LAN controller. And think of these interfaces as being logical interfaces. In our lab, we're going to take these interfaces and map them to physical port 1. Now you can see here there's static interfaces and dynamic interfaces. On the static interfaces there are two. There's the management interface and the AP manager interface. The management interface is used for in-band management, say for instance if you wanted to do authentication services. When you connect to the wireless LAN controller with a GUI interface to do your configuration, you will use the IP address that's assigned to the management interface. So remember that. Then you've got an AP manager, and this is the interface that's used for layer 3 communications, whereas layer 2 is on the management interface. So this is the address where packets are sent to from a tunneling perspective. So things when things are tunneled in the CAT-WAP tunnel is going to use the AP manager interface. Now if you do happen to use link aggregation, then you want to make sure you only have one single AP management interface. If you're going to use separate ports on your wireless LAN controller, then you can have an AP management interface attached to each port. You'll notice in this diagram above the AP manager is a virtual interface. And this one is basically any unused gateway IP address, and it can be used to help with mobility management when you roam between wireless controllers. And so make sure that all your wireless LAN controllers within a mobility group that you want to roam across have the same virtual gateway address defined on this virtual interface. Typically you just set it to 1.1.1.1. That's what you most commonly see. Now let's talk about those dynamic interfaces. You can see here that the VLAN is mapping to the dynamic interface in a one-to-one manner. In fact, sometimes these interfaces are sometimes called VLAN interfaces for that reason. And this is where your user data will be sent. So if I have VLAN 10, VLAN 11, etc., those will be mapped to a specific dynamic interface. And normally I give that interface the same number as the VLAN. These interfaces therefore are configured. You'd put in the VLAN ID, the physical port assignment, DHCP connections, and you can also put control lists on these dynamic interfaces. Now remember, when you create a wireless LAN for different SSIDs, those will be mapped to different dynamic interfaces, and in this way I can have an SSID for my employees with one security profile and another SSID for maybe guests with a different security profile, because they're going to be mapped to different dynamic interfaces on the wireless LAN controller. So first of all, I want to show you how the lab is set up, because we're going to take a look at each of these nodes. So the first thing I want you to notice is that I have a switch. I have a Catalyst 3560 layer 3 switch. I have a lightweight access point, a 3500. In fact, 3500 only operates in lightweight mode. And then I have a wireless LAN controller, one of the older 2106. My gigabit Ethernet port G13 is set up as an access port connected to my wireless access point, and my gigabit Ethernet port 01 is set up to my wireless LAN controller as a trunk port. I'm connecting with a laptop. I have the laptop running server 2003, and so that is my DNS server and also my wireless communication system. I'm also going to access the WLC through the web GUI. You will notice that on the wireless LAN controller I've configured it with a management interface of 192.168.60.2, and my AP management interface is 192.168.60.3. My wireless access point is coming in on VLAN 5, and I've put my control information, i.e. my management, my AP management, my DNS traffic, my TCS traffic, I've put that all on VLAN 60. So this wireless access point will map through VLAN 5 over here to a dynamic interface on the wireless LAN controller of 10.5.5.2. In this scenario, I have DHCP set up on the switch, and that will force the access point to acquire dynamically its IP address, and I've scoped it such that it will acquire an IP address 101 to 254. So let's take a look at the configuration that my lab is currently using. So the first thing I want to do is I want to connect to the switch to show you the switch config. And so you can see here I'm going to connect on COMS 6, which is where the cable's coming in. You can see the speed that I've set it to is a serial connection. And I just select open. So here I'm just going to do running config to show you the configuration. You can see here, I'm just calling it switch 1. It's got the version that I'm running. You can see here that I've set up DHCP to run on the switch. Here's the excluded addresses. And so as I mentioned, when my access points connect on this port, I can give them a IP address within this range. My DNS server here is the address. It's a separate server. We can see this is my first interface where I'm connecting with a trunk through to the wireless LAN controller. I've set it up as trunk mode, and I have set it to encapsulation 802.1q. I have set up, in this case, a native VLAN. VLAN 60 is very important to do that if you want this to work. And then I'm allowing not only VLAN 60 but also VLAN 5 because that's where I have my access port on. My access point is currently connected on port 13, and you can see I have it set up as an access port. It has VLAN 5 and the access mode is VLAN. Here, this is where I have my Windows Server 2003 connecting. That's running DNS and Wireless Control System, WCS. Is set up as an access port and also on VLAN 60. Here you can see I've set up the interface VLAN 5 and I've given it an IP address, and similarly here I've set up interface VLAN 60 because this is a layer 3 switch I'm using, and I've given that an IP address as well. So I've now gone ahead and connected to my Windows Server 2003, and up here you can see I've opened up Internet Explorer and I've keyed in the IP address of the access controller, 192.168.62. And so I want to go into the web GUI of the controller. So I type login. So I'm going to connect, and this brought me into the summary monitor screen. So let's first take a look at wireless, and you can see here that my access point has been discovered. So here's the model. You can see it's a 3500. It's brought in the MAC address. It's been enabled and is connected on port 1 of the access controller. If I now come here and hit the controller, we can come over here to interfaces, and you can see these are my static interfaces, my AP manager and my management interface. They are untagged, and here are the IP addresses. So my management one here is 192.168.60-2, and my AP manager is 192.168.63. Now if I click on the management one, here you can see that it's been set up with VLAN ID 0, and that's what makes it untagged. If I gave it a VLAN ID here, then it would be tagged, and all the frames coming in and out to that interface would have to have an 802.1q tag on them. Here's my IP address, my default router, my DHCP server, etc. If we take a look here at my VLAN 5, which is where my access point is connecting, all of these interfaces are coming in on one physical port, port 1. Here's my VLAN identifier, and here's the IP address that I've given it. The DHCP capability is my switch, and so that's my switch IP address. Here I can configure my wireless LAN configuration, and you can see I just have one configuration set up, Lab AP. If I click on that, you can see here that I have enabled it. It's doing a broadcast of the SSID, profile name Lab AP, SSID also Lab AP. And at this point in time I've set no layer 2, layer 3 security on this. So again, the main thing here is on the controller is with the interfaces that need to be set up correctly. So now you've had a chance to see the setup of my switch and my wireless LAN controller. Let's go ahead and take a brand new lightweight access point and connect it to the wireless LAN controller. So in this demo, we are going to now plug in a brand new access point and bring it up on our wireless controller. And you've already seen that I've already configured it to support one access point on port 13. And now we're going to bring up the second one. So I've plugged it into port 13. The lights are flashing, which means it's got power. So just configure T and then into the interface 0-15. I always like to give it a meaningful description. And this access point has external antennas, so I've called it 3500E. My other access point has internal antennas, so I've got two different models. And we want to do switch port access, and this time we're going to put it on VLAN 6. And then we want to just define this port as mode access. Now normally you would execute a no shutdown command, but I have actually already executed no shutdown on all of my ports in the lab, and again it's just to save myself time. Normal operations you would have all of these ports shut down that you're not in use. Let's take a look at our configuration. Now one of the things I have to do next is to go here and execute this command here to add VLAN 6. And here you can now see that I have configured port 15. So let's now go and configure port 1. And this time I want to do switch port trunk allowed VLANs, and I want to do 5, 6, and 60. So I just want to save this. Always want to have a quick look at my configuration. You never know. And here's my interface here. That's wonderful. Now there's one other thing that I need to do, and I need to make sure that it's set up to acquire an IP address. So I need to set up my pool. So let's go ahead and do that. So we call it a DHCP pool mypool 6. So we want to set up the network 10.6.6.0 255, put my network mask in, my domain name lab.com, DNS server is the IP address of my server 2003 60.4, and then I want to put in my default router. We make that 10.6.6.1. So default router of 10.6.6.1, enter the mask. And then we have to do option 43. So if you want to know what this is, so what it does is it defines the length and the type at the beginning, and then I put the IP address of the management interface. So in this case that's 0A050502 and then I put the IP address of the AP manager interface, and again I'm putting it in hex, so that's 0A050503. Hopefully I've got that right. And then I'm going to put in option 60, which is for this access point is a 3500, so is AP C3500, and I looked that up in the Getting Started guide at Cisco. I can exit that, and then I need to exclude some IP addresses. So I want to exclude DHCP, exclude addresses, and I'll exclude the first 100 in this example. So we just go from 10.6.6.6.100. And so that means when the access point connects, and any clients that connect to the access point, it will select an IP address between 101 and 254. Okay, so let's take a look at how that's configured it. So you can see here's my excluded address range, and here is my pool. Now it should be looking just like the one above, so let's make sure I didn't forget anything. All looks good. Let's see if my access point has acquired an IP address. I know what I forgot. I forgot to set up the interface VLAN. So see here where I've got interface VLAN 5, I need to set that one up. So I'm going into the interface VLAN 6. Give it a description, and then I need to give it an IP address. Okay, so now I want to take a look at see if it's got an IP address. So IP DHCP and bindings. There we go. So now we can see that my access point has indeed acquired an IP address. So we have now successfully configured the switch. Now we need to go and configure the access controller. So now we're back on my server 2003. So what we want to do is we're in the controller. Wants me to reconnect. And what we want to do is we want to set up a new interface. So I'll come over here and select new. Give this a name. And it's VLAN 6 we're going to set up. Give it a VLAN ID here. So I set apply. There we go. Give it a port number of 1. Remember, I have one trunk, and that's carrying my static management interfaces, and it's carrying my dynamic interfaces. And this is going to be VLAN number 6. Put in the IP address of the interface on the wireless LAN controller. So we give it 10.6.6.2. Subnetwork mask 255.255.255-0, and my gateway, we make that 10.6, give it 6.3. My DHCP server, of course, is my Windows Server 2003, so that's 192.168.60.4. Click apply. And now you can see I have successfully set up my VLAN. Now let's take a look and see if we found our access point. Here it is, and that didn't take too long this second time. So now you can see I've got my original 3500 and I've now got my second 3500 configured. So my access point is now registered on my wireless LAN controller. Thank you for listening.